have to find the derivative of the function y equals to 6s squared plus 4s plus 5 using first principle. It is similar to the just concluded question we solved. First, we write this question in standard form, which is y equals to f of x equals to 6s squared plus 4s plus 5. Alright, we name this what? Equation 1. This is the initial position of the function. So, what will be the new position when there is a change in x? So, we say y plus change in y equals to f of s plus change in x. What this implies that whenever we see s here, we replace it by s plus change in s. So this will be x 6 into s plus change in s all square plus 4 into s plus change in x plus 5. Okay. All right. We can further manipulate this. That is, we have y plus change in y equals to 6 into s plus change in s all square plus 4x plus 4 change in x plus 5. All right, we multiply everything here by 4. So that's what we did. That's what we just did. So now let's open this bracket. All right, let's leave everything here and let's solve. Let's open this bracket. So 6 into s plus change in s squared. This is empty as 6 into s plus change in x, s plus change in s. And this is empty as what? 6 into x into s plus change in x plus change in s into s plus change in x. Alright, now we can multiply. We have 6 into what? S squared plus s change in x plus x change in s, that is s times s squared, s times change in s change in s times s change in s plus change in s times change in s, that's change in s squared. These are together, so we can collect lightness and add this together. This will now be what? 6 into what? S squared plus 2s change in s plus change in s all squared. Now we can multiply through by 6. This will now be what? 6s squared plus 12s change in x plus 6 change in s squared. And this will be, this is what 6 into s plus change in s all squared is. Okay? Now that we've gotten what this is, now we can bring this back in here. Alright, we can bring this back in here. So now our y plus change in y is now y plus change in y equals to 6s squared plus 12s change in s plus 6 into change in s squared plus 4x plus 4 change in x plus 5. Is there any like times there? No. So let's call this equation 2. Alright, let's call this equation 2. Let's write it clearly. Equation 2. Alright, this is what our y plus change in y is. This what equation of y plus change in y. So now that we have found what we are given equation of y as a function of s. Now we are finding the equation of y plus change in y as a function of s plus change in s. So the next thing we are looking for here to find is to find our what? Our change in y. Now to find change in y here, all we have to do is what? We subtract both sides of equation 2 by y. That is, subtract both sides of equation 2 by y. This is equation 2, so we subtract both sides by y. So we have y plus change in y minus y. So the minus y takes the y away. So what we are left is what? Is the change in y that we are looking for. Now it will be what? 6s squared plus 12x change in x plus 6 into changing s all square plus 4x plus 4 changing x plus 5 minus y. Now recall that y, our y equals to what? 6x squared plus 4x plus 5. So we substitute this for y in this equation. Let's call this equation 3. So therefore we substitute for y in equation 3. Okay, so this equation 3 substitute for y. So then our change in y then will now equals to what? 6x squared plus 12x change in x plus 6 into change in s all square plus 4x plus 4 change in x plus 5 minus, what's our y? Our y is 6x squared plus 4x plus 5. I have to put everything here in what? In bracket, because the minus must come through everything. So we try and open that bracket, then our change in y equals to 6x squared plus 12x change in x plus 6 into change in s squared plus 4x plus 4 change in x plus 5 minus 6x squared minus 4x minus 5. So this we take this out. Why this we take this out and this we take this out? So our change in y will then equals to 12x change in x plus 6 change in s square plus 4 change in x. That's all. Okay, that's what is left. So from here now, the next step is to find our difference quotient. Our difference quotient is changing y over changing x. So what that implies that we divide all through by changing y. Let's call this equation 4, then divide both sides of equation 4 by changing x or delta s. So then we have changing y over changing s equals to 12x changing x over changing s plus 6 changing s all square over changing s, then plus 4 changing s over what? Changing s. So therefore our difference quotient will then be equals to 12x plus 6 changing x plus 4. So since you already have our difference quotient, let's call it equation 5. So we already have our difference quotient for the equation 5. So all that is left is to find the what? The derivative. So our derivative is what? Is the limit of our difference quotient when changing x tends to 0. That is, our derivative is the what? The y, the x, which is the what? The limit of changing y over changing s when changing s tends to 0. As changing s tends to 0. And what this implies, whenever you see changing s, you place it by 0. We have 12x plus 6 into 0 plus 4. So therefore our dy ds equals to 12x plus 4, and this is the derivative of the function 6s squared plus 4s plus 5 that we are given. Now we use the power function rule and the constant function rule. You know the derivative of a constant is 0, this will be 0. The derivative of 4s using power function rule is 4, and the derivative of 6s squared using power function rule is what? Is 12x. When you apply the sum of function rule, so we see that the final answer here is 12s plus 4.